Hello, everyone. My name is Samantha Hunter, and I work in the Policy Office at the National Science Foundation. It is my pleasure to welcome you today to the Spring 2022 NSF Virtual Grants Conference. I'm now pleased to present this session, which will cover the Directorate for Engineering, or ENG, or ENG. This session will be presented by Program Directors Carole Reed and Ying.
Good afternoon, everyone. We're going to be giving a talk on some of the opportunities within the NSF Directorate for Engineering. My name is Carole Reed. I'm a program officer in CBET, which is Chemical, Bioengineering, Environmental, and Transport Systems. And under that, I do a program called Electrochemical Systems.
My name is Ying. I'm program director at CBET with Carole. And so get back to Carole.
So first, I want to give you some context of NSF's strategic plan. And again, our mission is to promote the progress of science to advance the national health, prosperity, and welfare, and to secure the national defense and for other purposes. And in our strategic plan, we have goals of Empower, which is really to empower STEM talent to fully participate in science and engineering. Then we have Discover, of creating new knowledge about our universe, our world, and ourselves. And then we have Impact, to benefit society by translating this fundamental knowledge into solutions. And then we have Excel, to excel at NSF operations and management. Today, we're going to be talking about opportunities that really touch all these dimensions of scale. We have programs at NSF and in engineering from the single investigator level to mid-sized teams to centers and networks. We cover research programs that are at the single discipline or core research level to convergent team-based research. And we also cover the whole gamut of your career stage, from undergraduate to graduate students to postdocs to early to middle and later career. And then we also have programs to help translate the basic knowledge into solutions. So here's just some numbers from FY21, and this is for engineering. And you can see our FY21 budget of about $767 million, and how many proposals we've processed, which kind of makes me tired just looking at it, and some of the stats of how we've translated these proposals into awards, and most importantly, the impact of supporting the senior researchers, postdoctoral associates, graduate students, undergraduates, and other professionals. So I will now hand it over to my colleague, Ying.
Thank you, Carole. Let me introduce some cross-NSF opportunities for engineering. Well, first is artificial intelligence. That is one of the cross-cutting emerging technologies that engineering directorate supports. The goal is to expand the AI frontiers to create transformational technology and breakthroughs benefiting both science and the society. We have been actively supporting National AI Research Institute. In FY21, engineering supported 3 of the 11 new National AI Research Institute in the area of dynamic system and optimization. This year, there are 6 themes of the National AI Research Institute. Engineering also participate in the NSF Smart Health and biomedical research in the area of AI advanced data science. This has a deadline in November. Another emerging technology is quantum science and engineering, is to enable design of devices, applications, tools, or system with a quantum-based advantage over classical counterparts. In FY21, 2 new NSF Quantum Leap Challenge Institute were established. The Apps Core Research Infrastructure Improvement Funding supported a Nebraska collaboration focused on emergent quantum materials and technologies. There was also a solicitation on quantum interconnect challenges for transformational advances in quantum systems. In FY22, Engineering Directorate continues to support expanding capacity in quantum information science and engineering. There is an ongoing Dear Colleague letter on quantum manufacturing. Please check it out if you're working in the related area. In advanced wireless, NSF Spectrum Innovation Initiative aims at advancing areas critical to making future wireless technology and networks faster, smarter, and more responsive and robust. FY22 opportunities in advanced wireless includes the spectrum of wireless innovation enabled by future technology, or the SWIFT program, to support spectrum utilization, on-demand spectrum access, and resilient coexistence, challenges to passive observation from spaceborne transmitters. There's also opportunity on national radio dynamic zones with satellite coming in June. The Resilient and Intelligent NextG system virtual organization, the RINS-VO program, has a deadline in August. Semiconductor is another area of national priority. Engineering has organized several workshops in 2021 and identified challenges in semiconductor innovation and manufacturing ecosystem, including new materials and devices with added integrated functionality, infrastructure in short to long terms, support for the next generation workforce. NSF Semiconductor Research Cooperation Partnership to support research experiences for undergrads with REU sites on the semiconductor topic will be available later this year. Semiconductor synthetic biology circuits and communication for information storage is currently under review. Future of semiconductor teaming for co-design research capacity solicitation was recently published with a deadline on July 18, 2022. Everyone would agree with me the importance of pandemic prevention. NSF has a program called Predictive Intelligence for Pandemic Prevention, PIPP, that supports fundamental research and the capabilities needed to tackle grand challenges in infectious disease pandemics through prediction, monitoring, mitigation, and prevention. In FY22, phase 1 is to support development grants, and the proposals are currently under review. It is anticipated that phase 2 center grant solicitation will be released in FY23. This program is jointly supported by Bio, Science, Engineering, and SBE directorates. In climate change, the critical aspect of sustainability, innovative solution to climate change DCL encourages forward-thinking research that will aid in the nation's goal of reaching net zero greenhouse gas emissions and developing approaches for adapting to the changes that is already occurring. In this DCL, that is a rolling submission with 5 broad themes, including reducing greenhouse gas emission and energy use, energy innovations relevant to climate change mitigation, enhancing greenhouse gas sequestration, accelerating strategies for climate change adaptation, and synergistic topics. Another emerging technology that engineering plays an important role is biotechnology to understand and harness biological processes, enabling future innovations in therapeutics, pharmaceutics, biochemical, and biotechnology industries. Opportunity in this area includes RICO, which is reproducible cells, and organoids via detector differentiation and coding, accelerating innovation in biomanufacturing approaches through collaboration between NSF and the DOE-funded Agile Biofoundries, which has a deadline in March of 2023. There's also a Dear Colleague letter, Sentinel system that detect, recognize, accurate, and mitigate emergent biological threats. Check those out if you're interested in these opportunities. Future Manufacturing is a program that started in FY22 to enable manufacturing that either doesn't exist today or exists only at such small scales that is not viable. With 3 themes in biomanufacturing, cyber manufacturing, and eco-manufacturing. In FY21, NSF supported 22 new research and seed grants totaling $31.5 million. The proposals for FY22 are currently under review. Well, now let's move on to the engineering directorate opportunities. There are four major funding mechanisms in engineering. The first one is core or unsolicited, usually 2 to 4 years to support individuals or small collaborative teams with funds increase for collaboration. The second one is solicitations. Those can range from small to large funding size. Multiple divisions directly can be involved. Solicitation often include special research and education costs, research instrumentation and infrastructure, and center and networks. The third type is workshops and conferences to identify future research opportunities, form collaborative teams, build research and education capabilities. The last one is Dear Colleague letters for special opportunities for supplement or topics within current programs. Here are some advice for unsolicited proposals submitted to engineering core programs. New proposals may be submitted to engineering core program at any time. So please think more creative about proposed work. Take your time, build strong collaborations, communicate with program directors, and then carefully prepare proposals. Make sure they adhere to NSF newly published proposal guidelines. This is the organization chart of the engineering directorate, led by Assistant Director Susan Maglis. Engineering has 3 disciplinary divisions: CBET, CMMI, ECCS, and also one that manages centers, networks, education, diversity activities, EEC. The IFMA office leads cross-disciplinary activities. Many programs involve multiple divisions and directorates. So now let's go through areas of interest in each division. The CBET division includes 4 clusters. Chemical process systems supports fundamental research for the development of novel materials, mechanisms, and tools to improve the efficiency, resource utilization, and intensification of chemical processes. Engineering biology and health supports engineering research to improve human health and the understanding of biological and physiological systems. Environmental engineering and sustainability 6 projects that identify, monitor, and mitigate impacts of heat, advance resource and energy conservation and recovery, and support cost-effective solutions to protect ecological and human health. Transport phenomena support single and multi-phase flow dynamics, particularly heat and mass transfer, and combustion and fire dynamics. CMMI division has 5 programs. Advanced manufacturing program supports fundamental manufacturing research that address issues related to national prosperity and security, and has the potential to contribute to the revitalization of American manufacturing. Dynamics control and recognition program supports modeling, analysis, diagnostics, measurement, and control of dynamical systems. Engineering for civil infrastructure program supports fundamental research in geotechnical, structural, materials, architectural, and coastal engineering. Mechanics and engineering materials programs support advances in the transformation and use of engineering materials. Operation and design support design, operation, optimization, and control to advance the complex engineering and technical program critical to society. The ECCS division has 3 main areas of interest. First is fundamental research issues at the nano, micro, and macro scales, underlying device and component technology for energy, power, controls, networks, communication, computation, and sensing applications. The second is research on systems and networks for advancing engineering applications. The third is education of diverse workforce in electrical and computer engineering, to meet the technical challenges of the 21st century global economy. The Engineering Education and Centers Division supports broadening participation in engineering to enhance inclusion and participation in engineering by addressing structural inequalities and biases within education and workforce systems. The systems and networks is to provide the structure, coordination, and resources to solve engineering grant challenges and launch new industries. The engineering education is to encourage educational research to create and support an innovative and inclusive technical workforce for the future. And finally, engineering workforce development is to support pilot initiatives and meaningful research experiences that provide insights into concept, innovation, and careers. Here, we would like to highlight the broadening participation in engineering program that has two new tracks. One is on Inclusive Mentoring Hub, and the other is on Center for Equity in Engineering. The target date is November 16, 2022. Another opportunity is revolutionizing engineering department with the goal to catalyze revolutionary changes to the education of the next generation of engineers, while expanding the reach of changes that have proven effective innovation, adaptation, and implementation. And a new 2-year track for radically new approaches among 2-year institutions to expand pathway to engineering and engineering technology education. So now let's get back to my colleague, Carole.
Thank you. You've previously heard a number of the core programs that we have in engineering, and I'm going to continue kind of giving you an idea of some of the special topic solicitations that are also available in engineering. So what these 4 programs are common are what we call mid-scale engineering research programs. Each division in engineering has one. We have Ascent in ECCS of addressing system challenges through engineering teams. In my division, CBET, we have ECHO CBET of environmental convergence opportunities. And then we have in CMMI, the leading engineering for America's prosperity, health, and infrastructure, or LEAP-HI. And in the EFMA office, we have the Emerging Frontiers in Research and Innovation. So all these programs are team-based research projects between 1.5 to 2 million total over about usually up to 4 years. And so these are small teams, basically up to 4 or 5 investigators working together. So in the EFMA program, again, EFRI, NSF is all about acronyms if you haven't noticed. So Emerging Frontiers in Research and Innovation. Typically every 2 years, EFRI does a competition for research topics. And so this is the second year that these 2 research topics are being held. The first one is Engineered Living System, that really leverages the capacity of living organisms and cells to design, fabricate, and manufacture and model engineered living systems. And the other topic is brain-inspired dynamics for engineering energy-efficient circuits and artificial intelligence. And this basically applies and leverages the knowledge from neuroscience to leverage the unique features of biological learning and decision-making for AI systems. And so the first cycle of these topics has been run this year, but you can see at the bottom of the slide that the second is going to be underway. So for example, letters of intent are due next September for this second round that these 2 topics will be run in engineering. I'll now cover some of the center type projects that we have within engineering, covering the engineering research centers, ERCs, and industry university cooperative research centers, IUCRCs. First, I'll cover the ERCs. ERCs have been around for over 30 years, and they're team-based research. Usually these are a maximum of 10-year projects. and they support broad, multidisciplinary, high impact, high risk, high payoff engineering research. ERCs are in their fourth generation, and it emphasizes integrating convergent research that addresses a national need. And then the engineering workforce development, a culture of diversity and inclusion, and an innovation ecosystem for societal impact. Currently, there are 14 ERCs, and you can see the span of where these ERCs are operating in terms of involving 44 unique institutions currently. So as I said, we're at the fourth generation of ERCs, and they're advancing engineering knowledge and engineered systems technology while really exposing students and the faculty to integrative aspects of engineered systems industrial practice. So it really focuses on a convergent research approach that will lead to strong societal impact. It has a core program of engineering workforce development for participation of students at numerous stages. It also includes a culture of diversity and inclusion where all participants can benefit. And then it has this value creation or translation of the fundamental knowledge within an innovation ecosystem. And so typically ERCs have a new solicitation about every other year. And in FY22, we see that NSF 22-580, their letters of intent are due next September. And this is the cycle for the next ERCs that would be awarded in the summer of 2024. IUCRCs, again, Industry University Cooperative Research Centers, is another type of center that we have within engineering. These are also teams of universities working with industry partners. They advance pre-competitive research that drives innovation and develops a diverse science and engineering workforce by enabling close and sustained engagement between academia, government, and industry. So in these types of centers, the funds are leveraged on an average of 6-to-1. So there's heavy industry involvement, multiple universities, and currently we have approximately 84 IUCRCs operating in FY21, involving more than 110 universities. And then you can see all the stats of this type of center really across the nation. So I want to transition to kind of focus about all the opportunities we have for you along various points of your career path, covering from undergraduate to graduate students to mid-career faculty, and also throughout your career. So for students, again, NSF Engineering participates in the research experience for our undergraduate program. And we also have programs that really focus on research experiences and mentoring. And we have supplements for student design. And then, of course, we also benefit the Graduate Research Fellowship Program of the Foundation. And then we have supplemental funding opportunity for skills training in advanced research and technology, and also intern for non-academic research internships for graduate students. So for undergrads and graduate students, there are a number of opportunities that can be assessed through these various engineering and also foundation programs. For early career faculty, we have a number of programs. We have, for postdocs, we have a special program for fellowships. And again, we're accepting applications for the fall 2022 cohort. And this is basically facilitated through the American Society of Engineering Education. And we give you the link to find out about that. And for early career faculty who have not been funded for federal funds, we have the Engineering Research Initiation. We did the first cycle last year. We have a new solicitation that's on the street, 22-585, which is due in October 11th. And a special feature of this is, again, it's trying to target investigators who have not yet received federal funding, and also for those who are not affiliated with very high research activity or R1 institutions. We also have we also participate in the foundation-wide Faculty Early Career Development Program, or CAREER. And the next submission for CAREER is at the end of July, the fourth Wednesday in July, July 27th, 2022. And this is for assistant professors or assistant professors equivalent. We recognize that the special support is also needed for mid-career faculty. And so here's two example programs. In our CMMI division, we have the Boosting Research Ideas for Transformative and Equitable Advances in Engineering, BRIGHT. And it has a number of tracks to help experienced researchers forge new directions to basically either enrich their existing program or start out on a new emphasis. Engineering also participates in the Foundation Mid-Career Advancement Program, which has similar aims. We offer through existing grant supplements, for example, career life balance supplements. And CBET has a solicitation with chemistry on reentry to active research program for those research that were research active and had some sort of hiatus from research. And this offers an opportunity to get back into active research. I'll then cover briefly some of the infrastructure that engineering has to help bolster the resources that you have at your own institution to further enrich your individual research programs. So here's three examples. We have the Natural Hazards Engineering Research Infrastructure, and this has experimental facilities for extreme wind, water, and earthquake events. And we give the website for that, that's Design Safe. Then we have the National Nanotechnology Coordinated Infrastructure, the NNCI. And these are user facilities really across the country for both fabrication and characterization tools and instruments. So these are, again, different additional infrastructure that you can tap into to help enrich your own research program. Similarly, we have the Network for Computational Nanotechnology, NanoHub, and this has cyber resource for nanotechnology theory, modeling, and simulation, and also educational content in nodes in nanomanufacturing and nanobio. Engineering also participates in the mid-scale infrastructure. This provides investments for experimental research capabilities in the range between major research instrumentation, 6 million, and major facilities, 100 million. And so we have basically two tracks from it, and we have the mid-scale R1. An example of this is the National Full-Scale Testing Infrastructure for Community Hardening in Extreme Wind, Surge, and Wave Events. And this project is led by Florida International University. And then we have the mid-scale two projects that are currently under review. And I want to alert you to this new Dear Colleague letter 22-075 for conferences to help inform future mid-scale research needs and teams. A number of workshops were held previously, and out of those workshops were developed proposals for this effort. We also have the NSF Includes program, and this purpose is to enhance U.S. leadership in science and engineering by developing STEM talent from all sectors of our society. And so it included both planning grants to help capacity building and also alliances. And so it's through these alliances that have formed a collaborative research infrastructure to help provide additional resources for broadening participation. And so we include a website for the National NSF Includes National Network on resources you can basically tap into to help in broadening participation and also in developing STEM talent. Engineering has also recently launched this effort of Engineering Research Visioning Alliance, ERVA, and its purpose is really to obtain and integrate input from all sorts of stakeholders from academia, industry, societies, government agencies, and the public on the nascent opportunities and priorities in engineering research. So it has been holding a series of workshops to get from the community what are the most nascent and most impactful research priorities for engineering. And we include the website, the irvacommunity.org website, to learn on the various visioning workshops that it has held and that is planning in the near future. So we've given you a lot of information today. So just to recap, submitting proposals, you can submit a proposal for engineering to the core programs. Again, we don't have any deadline for the core programs. And so we always really encourage you to talk to us program directors for your research idea. It's not required, but it's highly recommended. And we really recommend you send a one-pager, a project summary, to your program director. Our emails are all listed on the programs or on the solicitations. The best way to figure out on how to do a better proposal is to serve as a panelist reviewer or an ad hoc reviewer. And we always encourage you to follow the program submission deadlines in the PAPPG, currently 22-1, or in any special requirements that are in solicitation. Again, NSF criteria are intellectual merit and broader impact, so you always want to reread the criteria and make sure that you're addressing that, because that's what the reviewers use to evaluate your proposal. Just mentioned it, but I'll mention it again. A good way to learn about programs and the NSF review processes is becoming a reviewer. How do you become a reviewer? Well, email us program directors. Again, our contacts are at the program. And it's a good idea to include your 2-page bio sketch. And in the email, put kind of keywords of your expertise. And in the tagline, the subject, to say, volunteer to be a reviewer. It's the best way to learn about the merit review process here at NSF and how to what goes into a good and compelling proposal. And with that, we thank you for your attention, and we'll be here to answer questions live. And thank you so much for your participation today.
Thank you so much for that, Carole and Ying. We look forward now to having more questions come in via the Q&A, so we can have the remainder of this hour to really chat with you all. So let's start. Well, before we go with the questions that are up there, Carole, thank you so much for mentioning the becoming a reviewer. Do you want to talk a little more about what some of the benefits of becoming a reviewer from the engineering perspective?
Yeah, so think of for a solicitation, it always has particular aims. And so if you're interested in a solicitation, but maybe your project isn't particularly ready to, or your project team isn't particularly ready to apply during that submission cycle, it's a way to find out about the proposals of, what goes into the proposals, what are the general trends, and also the process of how a proposal is discussed, and kind of the messaging that is in a proposal to the reviewers, and how reviewers can interpret things, and sometimes how pitfalls that the PI might get into that causes the reviewers to get confused. So it's a great opportunity, not only for special solicitations, but again, for core programs. Each core program really represents a discipline area, a special set of topics. And the programs, the core programs in engineering are in general quite diverse. And so in terms of topic areas, and so it also gives you an idea of the general topics that are coming in, and also, again, this key process, and also how the criteria are interpreted, and the process of actually evaluating the proposal on its merits, and how that kind of happens.
Okay, thank you. So I'll move to a question. Are there career funding opportunities for mid-career academics at R1 institutions with no previous federal funding?
Well, of course, all programs at NSF, all the core programs certainly are open to all investigators, regardless of your stage, whether you're assistant or or even non-tenure track assistant, associate or full professor. So that's one thing. I was just taking some notes. I think the bright opportunity, BRITE, I think that was mentioned in our CMMI division, which is Civil, Mechanical, and Manufacturing Innovation, has a number of different tracks that target the opportunities for mid-career faculty to restart or reignite their research programs. In my home division, CBET, which is Chemical, Bioengineering, Environmental, and Transport Systems, we have a program called RARE, which we also work with the Division of Chemistry in the Mathematical and Physical Sciences Directorate. That is an opportunity for those researchers, regardless of rank, who have experienced a hiatus that caused them to become research inactive. And so this is an opportunity for those types of investigators to propose a proposal to a core program within CBET or chemistry to help restart their research program.
Okay. And how long after enrolling in an assistant professor position is one still eligible to apply for a career grant?
Okay, so career, the eligibility is not tied to your how long you've been at your institution. It really, your status as of the submission date really determines your eligibility. And strictly speaking, NSF does not determine eligibility. Your institution certifies your eligibility using the criteria through the department letter. And so there's a number of, I don't have them in front of me, I should know them, but of having a PhD in a relative area, doing research in the area. Most importantly, you cannot have applied more than 3 times, meaning going through the review for a career proposal. That's the key thing, is really the number of tries of going through the review, and that you meet the criteria as of the submission deadline. So, for example, if you're an assistant professor and you've been notified that but that tenure take effect until, say, August or September 1st, our deadline is July 27th this cycle. So as long as your institution certifies your eligibility, that you meet those requirements as of July 27th, you would still, and you don't have those other 3 tries, you could be eligible to submit to career.
Okay, thank you. Now, NSF limits PIs to only 2 proposals per year. In 2022, engineering research initiation will begin to allow senior personnel. If one faculty serves as senior personnel in one ERI, does it count as 1 proposal towards the above limitation, or of 2 proposals per year for the PI?
I'm not sure where this person is getting this NSF limits PIs to only 2 proposals per year. I don't believe that is the case. That might be a particular requirement under a particular solicitation. Sometimes solicitations have limitations on how many proposals a particular PI can put forward or participate in various roles. So I would caution the questioner just to where they got that, because that is not an NSF limit. For ERI, this is the Engineering Research Initiation. This is a program from Engineering Directorate, and it's really targeted at non-R1 investigators who have not yet obtained federal funding. And I just want to highlight that the next cycle is due October 11th. And I would just look at the requirements for the solicitation. It does allow you to have budget for senior personnel. Now, senior personnel is kind of more of a budget term. For the ERI, there are no co-investigators or co-PIs on the cover sheet. And so similar, and that's in that regard, it's also similar to career, which does not allow co-investigators on the cover sheet. But for ERI, it does allow you to have budget for a senior personnel, which could be a collaborator, But, I would read the solicitation and also talk to the program directors of the program or programs you think you might align with your research idea. Because for the ERI, for this particular role, it has a lot of benefits to do that, but you also don't want to have it come across that it's a major role in your project, because an ERI is really about your initiation, kind of a seed funding for your research program.
Okay, thank you. And again, to echo what Carole said, you want to be sure that you're not applying what's in a specific solicitation, applying that across the board for all NSF proposals, all requirements. A solicitation may limit the number that an individual may be a PI on a proposal, but overall, the guidelines, the guidance in the PAC guide, Proposal and Award Policies and Procedures guide, does not have that limitation there. So that will be more, the PAC guide will be more general. The solicitation will tell you exactly what's expected for that submission. Okay. Another question, will there be FOA for other engineering areas in the future? For example, mining provides raw materials to all areas, but FOA in mining, engineering, and extraction technologies are almost non-existent.
Right. So I think that's one of the kind of the wonders of NSF is its flexibility to respond to societal needs and also new areas of science and engineering that are being developed. So, I would note that there are fundamental research topics that probably could fit in the existing core programs that would support this general application area. And so one thing is NSF is really divided by discipline. So for example, in my home division, we have a program called interfacial engineering. And I know there's some projects that go in there that do help support understanding of, for example, recovery of rare metals. And we also have a program called environmental engineering and also environmental sustainability that cover some of the research questions that might support this field. We also have, we talked about the EFRI program, Emerging Frontiers in Engineering. EFRI, Emerging Engineering Frontiers in Research. We'll put it that way. And that's why we have acronyms, so that people like me who forget what they stand for just says the EFRI, E-F-R-I, in our EFMA office. This is a program that every 2 years comes up with emerging topics that engineering plays a role in helping to understand. And so typically every other year, there's actually a public call to the research community on research needs on these research topics. And so I would definitely look out for that, because they typically result in solicitations. And so we kind of briefly described the one on brain-inspired computing, and also the sustainable materials one as well that are active, but that's also a vehicle. And then also we have this new IRVA mechanism that also may help develop these types of research ideas into potential future topics.
Okay. And EFRI, as a reminder, Emerging Frontiers in Research and Innovation. So there we go. So another question for the REU program, is staff salary support an allowable cost to support coordinating applications, students, et cetera?
I would definitely look at the PAC-G guide for allowable expenses. I don't think so, but I don't know exactly. So I would work with your sponsored research office on what is allowed in terms of expense for an REU supplement. And I'm talking supplement, I'm interpreting this as a supplement versus a REU site proposal to a REU site solicitation. But if it's for the site solicitation, I would read the solicitation and also the PAC-G on allowable expenses and talk with your sponsored research office if it's a supplement to your existing grant. I don't know, Samantha, do you have anything to that?
No, that is the exact answer would be, you would speak in-house. And I know a lot of times our audience we have research administrators in the audience, but oftentimes for the breakout sessions, we have more faculty. So that is exactly who we would say turn to, the research administrators for that, after looking at the solicitation and the PAP guide for allowable costs. Okay. And how important is it to have prior publication in the field in which you are proposing research?
This is kind of along the topic of preliminary data. We get that a lot. PIs asking program officers on the level of preliminary data that you would include for the proposal. So I kind of include that under publications as well. Of course, you don't want to have done all the project before the project is actually funded. I see as preliminary data or publications really fulfilling two main purposes. One is your expertise and capability to perform the work. And so publications or even publications that are in review, peer-reviewed publications, they can attest to that. And also, published data that you provide in a proposal can basically establish that you have the expertise to do the work of those particular experiments, for example. Preliminary data, also the other purpose I think of it as, there might be a particular, in your project, a particular piece that's high risk, and that's okay because we're NSF, we want to fund high risk, high reward research, but reviewers want to see a project fall apart if one piece of it doesn't work as planned. And so preliminary data, and it's not even just yours preliminary data, you might also make the case using data in the literature, might provide that basically feasibility that the reviewers are looking for that particular piece of the project to assuage that type of concern.
Okay. And does the CMMI accept RUI proposals? And if yes, is there any limit on number of proposals per PI or co-PI?
Well, RUI for the audience is research at undergraduate institutions. It's a solicitation. And so it's not just CMMI. The engineering core programs of all of our divisions accept RUI proposals. I would, there is not a limit of number of proposals that can be submitted. I don't even think there's a limit on PI or PIs or something. In fact, an RUI can also be in a collaborative proposal with a non-RUI institution. I've seen those as well. So I would definitely look at the requirements of the RUI and maybe just Google RUI and NSF and you can kind of get to that page. But it is a type of what we call an unsolicited proposal that is to a core program. And so I'll just end it there.
Okay. And this was, I know we talked about it a second time, but so I don't know when the question came in, but they're asking again for further clarification, how many proposals can be applied for NSF per year, including career awards? Like I said, I know we talked about that, but go ahead.
Well, okay, well, you can submit as many proposals during a cycle as you like. Of course, they all have to be different. For career is a solicitation, and it does have a requirement that you can only submit one career proposal during a cycle, and you have 3 tries to go through review. So again, for the core programs, there are no limits on number of proposals you can submit. Of course, they all have to be different. I would definitely talk to program directors if you're thinking of submitting more than one. Again, there's no requirements in engineering to contact the program director or anything, but it's good to always get their input on program fit. And again, it's really solicitations that sometimes have these requirements of number of proposals that you can submit for a given cycle or in a particular track. You know, those types of requirements are usually at the solicitation level.
And with when you submit multiple ones, as Carole said, obviously they have to be very different. And the solicitation did not restrict how many can be submitted. But you also, in completing the current and pending support information, you are then, letting NSF know where all you might be stretched. So the proposals you've submitted will be pending because they have not been awarded at this time if they have just been submitted. So, NSF would look at, okay, where's your, do you have the capacity to do it as far as time? Is your time allowing you to do the work that you're proposing? So while you can submit as many as you like, depending on the solicitation that you're responding to, you still have to account for your time, so that is something to keep in mind as well. But there is no hard and fast restriction on it unless the solicitation states so. Okay, can we add a mentoring plan to the ERI proposal?
I would just check the requirements of the solicitation of what the supplementary documents are. I know there is a departmental letter that chief's concern is establishing eligibility and that your project is kind of aligned with your department's mission and your institution's mission. Off the top of my head, I'm not sure about a mentoring plan. But if that's always a topic that you might want that you could include in the discussion in your project description. But I would check to the actual requirements in the solicitation, which for ERI is 22-595. And again, this next cycle, this is the second time we've run it, and the proposals are due October 11th, 5 o'clock local time, 5 p.m. local time.
And some directorates or programs suggest that new tenure track faculty first apply for small or projects before proceeding and applying to career program. What is the vision for engineering directorate regarding new PIs?
I don't think there is one. I would just say that I think this is a discussion more with your mentors and your departmental chair on where you are in terms of your career at your particular institution and whether both you and your mentors think you are in the right stage of your career to participate in the career program, assuming eligibility for the career program. Myself as a program director, I don't usually like to give out that type of advice. I think that's really a discussion with your mentors and your departmental chair or your departmental chair equivalent. Okay. But I would emphasize that PIs of all stages of their career are eligible for the core programs and certainly except if it's specialized in the requirements of a solicitation for most solicitations as well. The career is not the only opportunity for early career faculty. I want to make sure you understand that. There's all the core programs, all special topic solicitations that early career faculty can apply to. Career is not your only bucket.
Yes. If a faculty has participated in a faculty development grant that was granted to the institution, does that count toward previous funding and ineligibility for ERI program?
I think it's best to send that question to the ERI team. I believe it's ERI. Let me get that second. The email is eri@nsf.gov. That's maybe I'll put that in the chat. That's an email for the ERI working group, and we've been going through the various questions that have been coming in for the solicitations. So I'll just put that for everyone.
Okay. And are there any limitations for the number of co-PIs for the CMMI proposal?
Well, this is kind of vague, but I'll just interpret this as a proposal to the core program. And again, I think there's just limits, 3 or 4 that are on the cover sheet. And then the rest would be potentially senior personnel. I think the more relevant question is really to talk to your program director about your project and the project scope, because the core programs are typically smaller budget size compared to maybe some special solicitations that might be more team-based projects. We certainly have small teams applying to the core programs and being successful. But the size of the project and the scope, that's definitely a conversation to have with the program director of the program that you're thinking that your research objectives would align with.
Okay, and what is the eligibility criteria to becoming a reviewer? And if I reach out to an NSF program manager about becoming a reviewer, should I expect to hear back from them, just because I've asked the question or expressed interest, or do they wait until there's a need for the reviewers?
All of us as program directors are all kind of unique and have different styles, but I would say, first of all, in general, to have probably a doctorate and, the expertise in the area. You don't have to have an active NSF grant to serve as a reviewer. You just have the expertise. So again, I as we kind of said in the talk, is email the program director of the program or programs, because it's probably more than one, that your research lab probably aligns with more than one core program. And maybe attach your 2-page bio sketch that you'll have to prepare anyway for an NSF proposal. And in the title, in the subject, put, volunteer to be a reviewer. And I said, put maybe keywords. As far as turnaround, we don't have deadlines for the core programs in engineering now. So we're doing, review panels really throughout the year now. And so, if you don't hear from a program director, don't be shy. It's okay to re-ping them and to see what's, just to get that towards the top. But we're trying, we try to have a mix of course, the expertise and all types of institutions and types of PIs when we're putting together the review panels.
Okay, thank you. One last question to close us out. If my proposal matches a few programs, can I submit it to different programs at the same time?
No, I think in general, each proposal is different. But, I think that's basically what we call determining program fit. If you have a project that you think aligns with more than one program, definitely talk to those program directors to see, what proposal would kind of, at least our opinion of where to most align. This is a particularly kind of hard question for career because you can only submit to one program at a time. So I think it's really in discussions with program directors to really understand their opinions of your project objectives, and then you can determine whether maybe your scope is too broad and you can realign your project to more fully fit within a particular program.
And you also, on the cover sheet, you also can say where you would like the proposal to go, or, under to what programs, where you want it submitted, so you're not shipping that proposal out. You're not submitting it to each of the multiple programs, but you are stating that here's where we want to go, 1 option, 2 option, 3 option. So that will be on there as well. Okay.
Right. So, you can indicate secondary programs where you think your proposal aligns to, and that we take that information as program directors. Yeah.
Yes. And for that last question, the PAP guide, Proposal and Award Policies and Procedures Guide, is where you would go for proposal preparation and submission instructions, as well as the solicitation. Okay.
Okay. Us as program directors, we work for you. So don't be shy about contacting us with your questions. If you don't hear from us, maybe in a week, it's okay. You can re-ping us again. If you have questions about your career idea, because this is like prime season for career, put maybe career in the subject line, because we're especially looking for those emails. That's a good maybe strategy.
Thank you so much, Carole, for all your insight and helping us get a better understanding of engineering and NSF as a whole. Thank you to the audience for joining us today. Thank you, everyone, for participating. Have a great rest of the day.